I'm Alex. I lead developer relations at Anthropic, and today I'm going to be showing you a coding task with computer use. So we're going to be showing Claude doing a website coding task by actually controlling my laptop. But before we start coding, we need an actual website for Claude to make changes to. So let's ask Claude to navigate to Claude.ai within my Chrome browser and ask Claude within Claude.ai to create a fun 90s themed personal homepage for itself. Claude opens Chrome, searches for Claude.ai, and then types in a prompt asking the other Claude to create a personal homepage for itself. Claude.ai returns some code, and that gets nicely rendered in an artifact on the right-hand side. That looks great, but I want to make a few changes to the website locally on my own computer. Let's ask Claude to download the file and then open it up in VS Code. Claude clicks the Save to File button, opens up VS Code, and then finds the file within my Downloads folder and opens it up. Perfect. Now that the file is up and running, let's ask Claude to start up a server so that we can actually view the file within our browser. Claude opens up the VS Code terminal and tries to start a server. But it hits an error. We don't actually have Python installed on our machine. But that's all right, because Claude realizes this by looking at the terminal output and then tries again with Python 3, which we do have installed on our machine. That works. So now the server's up and running. Now that we have the local server started, we can go manually take a look at the website within the browser. And it looks pretty good, but I noticed that there's actually an error in the terminal output, and we also have this missing file icon at the top here. Let's ask Claude to identify this error and then fix it within the file. Claude visually reads the terminal output and then opens up the Find and Replace tool in VS Code to find the line that's throwing the actual error. In this case, we just ask Claude to get rid of the error entirely, so it will just delete the whole line. Then Claude will save the file and automatically rerun the website. So now that the error is gone, let's go take a final look at our website, and we can see that the file icon has disappeared and the error is gone as well. Perfect. So that's coding with computer use and Claude. This took a few prompts now, but we can imagine in the future that Claude will be able to do tasks like this end to end.
Hi guys, I hope kila mtu anaweza nisikia. Kindly someone confirm kama mnanisikia. Hello. Can you guys hear me? Sawa, asante. Thanks Philip. We'll start by, so today we are going to try and implement a functionality. We're trying to build a simple chatbot application. I want to do 1 second. So this is the application we're not going to build the application today, all of it, but we're going to implement the functionality behind this application. I think it's going to be a 3-part series. So this is going to be part 1, where we build the chat interaction, where you ask a question and then it responds, and then later on we're going to implement other functionalities. So we're going to do a question like, so what is the latest news on Rigathi? So the application here is going to do a web search, and then once it does the web search, it's going to generate for us links which it has gotten the information from. So it does this input. It does a web search um, latest news regarding Gachagua, generates a response that has been gotten from these sources. So from the Star, there is this information, then there is this other information, like that. So the functionality you're going to implement today is the ability to ask a question. It doesn't necessarily going to focus on the search implementation today, but we're going to focus on asking a question, getting a response, and also the chat application to be able to store that conversation history such that you can ask it question regarding what just asked. So how long was he president? So since now it has context that we were talking about regarding Gachagua, you can ask a question like this: how long is he a DP? So it understands we are talking about Riggy, and it generates this response out of that. It doesn't do a search for this, but because it knows what we're talking about, it determines what it needs to do. So that's what you're going to build today. So the application, the framework that helps us build application that helps us build AI applications is called a Langchain. So I'm just going to present my whole window so that you can see. Yeah. So this application is called Langchain. Langchain is an application where it gives you certain tools for you to build AI applications like chatbots or agents and things like that. And you can build it in Python or in JavaScript. We're going to use JavaScript just because in the next talks that we're going to have, we're going to build also the front end so that you can have a fully fledged chatbot that you can chat with on the web. So these are the tools that it gives us. It gives us certain tools like web search. You can also do search on a vector database, things like that. It gives us models like OpenAI's GPT-4, Anthropic's Claude. You can also do local models like Llama. So these are the models. It gives us text splitters. So when you're building an AI application, um, the text that you use is usually split into things so that it's going to be split into chunks that are called tokens. So these are different text splitters depending on the model you are using. So different models have different splitters for you to split the text. You can also split this text in basic formats such that you just split it in word format, or you can split it in token format, or you can split it in individual letter format. So those are just text splitters. Output parsers are where you get a specific output. Like you want the output to be in JSON format, you want the output to be in string format. So those are those. Document loaders are where you want to upload a certain document like a PDF or a Word document. So Langchain also provides that. Vector stores, so there are different vector stores. When you're dealing with AI applications, the data that you store so that an AI application uses it is stored in embedded format, where instead of storing it in text format, it is stored in the number equivalent of those text. So when you're creating an AI application, you need to generate when you have a text, a large text, like say a book, you have a book and you need an AI application to have context of that book. You upload that book onto, let's say, OpenAI or Claude, and then it embeds that text. Embedding is a process of converting um, a piece of text from being string format into being a list of numbers, which are called embeddings. So those embeddings, which are equivalent format of the text, are the ones that are stored in a vector database. So vector database is the equivalent of just a normal database, but now this one is the one that holds the number equivalent of the text. I hope that makes sense. So now vector stores are now, you can have different vector stores. You can have one Chroma, there's another one called Qdrant, there's another one called Pinecone. They're different. We'll get to explore all this. So the other tool that it provides us, they are called prompts. Prompts are where when you're creating an AI system, you give it a prompt so that it behaves a certain way. So you can tell it respond only in French. So it takes in the input in English and responds in French. So that is a prompt that you've given it. So whatever happens down the conversation, it will always respond in French because that is the prompt you've given it. And we'll also see how these prompts help us to ensure that we keep the AI system from generating either malicious or also outside of its context. So if you want to build an AI system that generates that only answers questions in the legal space, give it a prompt and you tell it to only answer questions that are legal in nature. If not, it should say that it is not able to do so. So those are prompts. Example selectors, we will see a bit of this later on. So this is Langchain. You should go to this website and figure out how to use it. So today I'm going to give you a small introduction onto how we start building AI applications. So yeah, I'll present my my IDE so that you guys can see what the code writing. But if you want to follow along, you can go to js.langchain.com/docs/tutorials/chatbot. Let me see if I can post this link kwa chat here. Yeah, so if you want to follow along, I'm going to use this as my guide. I might not do exactly what they're doing, but this is a guide. I'm going to do different implementation so that we see it working on our side. Their implementation is using Google Colab, which we're not going to use right now. So we're going to implement it in the console so that we see how it works. So let me change my sharing. Come here. So so there are things we need to install first. We come to the terminal and let me clear this. Come to the terminal and you need to install npm install Langchain. Let me copy this. You need to install, so npm install Langchain core. Then you also need to install Langchain langgraph, and then you need to install UUID. So if you're following along, those are the things you need to install. I've already installed, but just install so that you see me doing it. So the Langchain core here, I hope you can see my code, my IDE. Yeah, you see the IDE. So yeah, so the Langchain core here, This provides us with the core packages that Langchain offer. When you continue to use Langchain, you'll notice that there are different ones. There's Langchain Core, there's Langchain Community Edition, where they've open sourced it such that people can build their own tools that the community can use. Then there's also Langchain Langgraph. Langgraph helps us to build agents. So when you're building an agent, you need the agent to have certain things within its context. So one of the things it needs to have is memory of the conversation that you're having. Another thing is you can also give it tools where it can do web search. For example, we saw that you can ask it a question like, what is the latest news on Rigathi Gachagua? And it does a web search, and then it generates for us a response. So when you're building an agent that can do that, you use a LangGraph. So LangGraph gives you the ability to connect a tool into your agent. Yeah, those are the few ones. There are also others. We'll get to see them more as we continue learning about Langchain. Finally, there is UUID. This UUID is just a normal NPM package that generates for us what do I call it? It is a string. It is a number that it is a unique number that you can use to reference your conversation. So, for example, you're having a conversation with, let me show you. So you're having a conversation with ChatGPT, and you ask it a random question like, when is today? So I've asked it, when is today? And up here, you want to be able to see it that way. Window. So I've asked it when is today. Up here, you can see that there's this number. This number here is generated by this package that we are calling UUID. So this is the number that references this conversation. It is a unique number, and the parameters that have been used to generate this number are such that it is not repeated. Like, you can't have two conversations that are being referenced by the same number. So you can research more on that UUID package. So yeah, okay. So those are the packages that you need to install. The last package that you need to install is called npm install at langchain /openai. I'm going to use OpenAI, but you can use whatever other model you want to use. So there's Anthropic here, there's Fireworks AI, there's Mistral, there's Grok, there's Vertex AI. So you can use different npm installs for different models that you want. I'm personally going to use OpenAI because that's the one that I have tokens for. If you want to follow along exactly the way I'm doing, we'll come here to platform.openai.com/assistance. And if you haven't created an account, you just sign up. I think you can sign up with your Google account. I think I personally use my Google account. So come here, sign in. Yeah, then you come here kwa you come, I think it's settings. Yeah, settings. Come to settings. Settings iko hapa kwa top right hand side, and then you come kwa billing. Ukishakuja kwa billing, you can see your credit right here. The minimum that you can top up when you come here, the minimum is $5. So that's around, I don't know, 700 I think it's 700 and something. So you can top up $5 and then you can follow along exactly the way I am doing. But if you don't have that 700 right now, it's fine. You can just follow along with what I am doing. Then once you have that, you can pay for your own tokens. It's extremely cheap. Once you pay for that 700 shillings, you can build so many applications and it won't incur you a big cost. So yeah, so this $0.36 you see here is going to last me until probably the end of the year. So yeah, that's it. So I'm going to use OpenAI, and then in my environment variables, I'm going to put OpenAI my API key. If you want to find your API key, you come to hapa bado tuko settings, you go to API keys, and then you see it here. So I've put this as augmenting intelligence, and then this is the key. Once you see this key once, you can never see it again. For you to actually get your key again, you will have to delete this one and generate a new key. So that's why it's just impossible for me to access it again. You see, there's no way for me to access it. So once you created a key, you copy it to somewhere safe, your environment variables. I'm going to show you, but I won't show you my key. So here kwa .env, so you come here and you create a .env, and then you do, so I can do something like .env. You can also do .local. .env.local means that this is local on your machine. .env only means that it can be locally on your machine, but also it can also be on your server, such that the application you're hosting, like for example, your website is being hosted on Vercel. Your .env file can also be hosted on Vercel, so that your environment variables are still accessible by your website when you've hosted it somewhere else, so that it's not just on your machine. So env.local, and then you come here, you do open AI API key, and you notice that I am doing, so this is someone else's random API key. So you notice that it starts with SK and then blah 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 blah. So whatever your API key is, and you ensure that it is capitals, and so that this is not put in string like this. You don't put quotation marks. You put it empty like that. So yeah, that's it. So now, since we've done up to there and we've installed Langchain, OpenAI, and Langchain Core, we can start building the application. Let me just show you that I have installed. Good. So we come here. Higher. So we start. So the first thing we need to do is to import the OpenAI implementation. So we do const do chat OpenAI like that. And if you want to have this what are they called, code suggestions like mine, I am using an AI tool called Codium. So you can come Codium. I think it gives you 14 days free, so you can check it out and implement it in your own IDE, if it is Visual Studio Code or it is like mine, WebStorm. You come there and then you say get Codium, and then you implement it in your own IDE. So it is called Codium. you can go to their website. If not that, you can also use Amazon Q. So Amazon Q is like what are they called? GitHub Copilot. So you come here and you ask a question, a random question. It generates for you code, and it can also input the code that generates here. It can also input it here in the place where you're writing the code. So those are the tools that I use for writing my code. I hope that will help you guys. So yeah, so we've imported OpenAI's implementation. Then we'll do const. You see, it even does it for me. So const LLM, like that. So const LLM new chat. New chat OpenAI. So we are using this package that we've installed, this function that we've required from this package. It's called chat OpenAI API, OpenAI, and then you call the API key like that. I don't know if it can see. Yeah, it can see. I think it can. And then model that temperature. This temperature part here is how creative you want the model to be. If you put it at 0, you're saying that you want it to be creative, that it doesn't hallucinate as much. You want it to be very grounded in what it is saying. If you increase this to, I think you can, I don't know if it does 0.5 or you do 5. I'm not sure about that. If you're not sure about something, you just come to the code here. I don't think you can find that right now. Temperature, just saying 0. It's a number, and I think it's a number up to 10. So see here, you can put 5, and it will be moderately creative, but we'll just keep it at 0 for now. Another thing I've noticed is that it is pulling from env.local, which I do not want. I want it to pull from the env file. So another thing I'll do is I'll do const I'll do require.env.config. So now the OpenAI API key that it is pulling, it is going from my .env file. The model here, this is very crucial. You should ensure that you're using GPT-4o mini. GPT-4o is the latest model that OpenAI has. They also have O1. O1 is the reasoning model, but the latest model that they have for normal chat conversations is GPT-4o. But this is more expensive than GPT-4o mini, and the mini is just as good as 4o, but it is not that good. It's just as good, but it is also faster, and it is a smaller in size, so it is quite fast in its execution. So that's what we do. So once we've done that, we can now invoke it. So it also suggests for me something, but we'll do await llm.invoke. That's how you call the LLM that you've chosen. If you're using chat OpenAI, or you're using chat Anthropic, you do llm.invoke, so that you call it, and then it takes in either a list of messages or message objects, or it takes in just one question. You can ask it one question, or you can ask it a list of multiple conversation turns. What we are going to do, we're going to do a list of message objects, and the object here is going to be role. The role is going to be role as user, and the content is going to be hello. We're also going to say hello, my name is Alvin, and then we're going to save the response of this piece of code. We're going to do const response like that, and then we're going to come here and do console.log response. But for those who are familiar with JavaScript, will know that this will generate an error if we try to run it. So we're going to come here, run. We don't generate an error. Why? Because it is saying await can only be used in a function that has async with it. So we're going to come here and do const main. No, not that main. Like that. And then we're going to copy this. We're going to, and then we're going to do async here so that await is working. Then come here and copy this console log out and paste it here. And then this is not going to work because main has not been called. So we're going to do main comment and do dot there so that error goes away. So now we can see up here that we have problems. So when we run it, it's going to tell us, going to give us a response. Here's the response. Response coming in as AI message with an ID, and the content here is, hello Alvin, how can I assist you today? So this has gone and called OpenAI's GPT-4 or Mini and generated this response and given us this response. We can see down here that we have a response metadata, such that token usage. The prompt tokens are this is a prompt token. Hello, my name is Alvin. If you change this from hello, my name is Alvin, you add here Alvin Kamau, you will notice that the prompt tokens will increase from 14. It will increase to more tokens being used. So we can run this. See now here, prompt token 16, because I add this word here, Kamau. Yeah, and completion tokens, these are the tokens that have been used that are different. You notice that atakama this string is longer than hello, my name is Alvin Kamau, but because hello Alvin Kamau, the tokens used in that part have already been used in the prompt token, they are not counted in the completion tokens, because the way the way the transformer architecture works is it has been trained to predict the next token, and if the token is being predicted among the ones that are being used for completion have already been used, you're not going to be charged by OpenAI for those. So that's why you're seeing that these from here, how can I assist it? Those are the tokens. But to make how are these tokens counted? The GPTs done by OpenAI, they have 50,500 and something, 67 tokens in their vocabulary. You see the way the English language has 27 letters, whatever number of letters. So now it's for the GPT architecture, they do not use letters, they use tokens. Tokens are subwords. So for example, for the large corpus, the large a corpus is a large thing. So the corpus of text that was used to train GPTs that are done by OpenAI have certain words, and what some of those words the GPT model has recognized that kuna zile phrases zinakuwa repeated a lot. So for example, hello, kuna the word hell in it, kuna the word pia he, kuna the word pia HEL that can be used with other letters that are coming after HEL that are not L itself. So kama the word held, I held the baby. So one of the tokens that can be used, I'm not sure if it is this one, but one of the tokens that can be used is the sub word HEL. So it can be one token. So that's how they are being counted. I think there's a way of checking token count OpenAI. Let me see if I can. There's an application. Great. So here, let me show you. Let's see if this will work. So the word hello, Alvin Kamau, how can I assist you today? So these are the tokens that are being used. So hello is a token on its own. Comma is a token on its own. Space, you see here there's a space between comma and the first letter of Alvin. So space, Alvin is a token on its own. Space, Cam is a token on its own. AU is a token like that. That's how they arrive at 13 tokens, but 14 characters. I hope that helps explain that discrepancy. So yeah, the rest are just repeating this information in different ways. The last thing I want us to one of the last things I want us to look at is this called system fingerprint. If you want a GPT model to generate the exact same output every time for a specific query, you keep this system fingerprint. This is the state at which the GPT model is at. So if you send in a prompt, it will always respond with the same output if this system fingerprint is this one. So if you have a different system fingerprint, it will generate a slightly different response. So it might not use my second name, but say, hello, Alvin, how can I assist you today? If the system fingerprint is different. Or if the system fingerprint is different, it might say, hey, how can I assist you today? And it completely ignores my name. So if you want it to respond in exactly the same way every single time for a specific input or for a specific prompt from the user, you retain this system fingerprint and you input it as a property in the LLM.invoke. We'll see how that is done. Then the last thing I want us to do is tool calls. So this is where when you've built your model, you will give it certain tools, like the one we've seen on Akili AI. It does a web search. So one of the tools here, if we had a web search implemented, it will show you that it has done a web search and the response of the web search here in tool calls. And if the tool calls failed or are invalid or don't exist, it will tell you, it will list the tool calls that are invalid here. Other than that, nothing else to know about that. So let us continue. I'm seeing that time has really gone. Let me try and finish haraka haraka. So yeah, that's what we've seen, that when we've done llm.invoke and it has a list. For those who are not familiar with JavaScript, a list is done by this box brackets, whatever. Then an object is done by these curly braces. So a list of message objects. This is a message object. So the list is in here, then the message object is there. If you do see that's response one, we come here and we do const response to await llm.invoke a list of an object. So role, what is my name? So we ask it, what is my name? For those who are already familiar with this, already know what the response will be. And for those who don't, I'll just show you that this will not work. Having it like this will not work. Now that will bring me to my next point. So let me run here. And then we will see the response. Okay, so we come here, we see the response of the AI message is, hello, Alvin Kamau, how can I assist you today? Which we've seen, and we've gone through how that that object holds. The next message here says, I'm sorry, but I do not have access to personal information about you unless you share it with me. How can I assist you today? But you might ask yourself, haven't I just told it that my name is Alvin Kamau? How is it then telling me that I haven't, like it doesn't have information about me unless I share with it? That will bring me to my next point, to implement conversation history or memory into an AI chatbot. So the first implementation we can do is a very rudimentary one. A simple one is going to be just to do this. We copy this, we remove it from there. Since I told you that this llm.invoke takes in a list of message objects, we come here and we paste this, and we paste it in the same indentation that you see how it looks. So you can see here that we've given it role that, hello, my name is Alvin Kamau, role user, what is my name? You can also add this one where it says, hello, Alvin Kamau, how can I assist you today? You can copy this, then you do role, it will be assistant. So the role assistant, then content. The content is the content that it has given us already. Content here. Let's remove this as characters. So now we put a comma here. So now this now is trying to simulate a conversation that someone has had with an AI assistant. You've told it, hello, my name is that, and the assistant has responded and told you, hello, Alvin, can I assist you today? Then you've asked it, what is my name? With this implementation, it should tell you that my name is Alvin Kamau. So let's see. Here, your name is Alvin Kamau. How can I assist you today, Alvin? You see? So this is essentially what we are going to try and simulate and emulate, but now using code and not doing it manually. So So we're going to start by building a graph. And as I said, a graph, this is how a graph looks like in LangGraph. It looks like this. So we have a start, and this start is connected to a certain node, a node called LLM. So the LLM that you're using. So for us, we're using OpenAI's LLM. And that LLM it's not a must, it just can have a function. And this function is what we are calling a tool. So it can have this function can be doing a web search. This function can also be doing a database search. This function can be doing anything really. And then it can have an end node. So a start node, and the model node, ama the LLM node, and then the end node. So this is how a simple graph looks like. They have to have a function. So uh, let me check if I'm still in the meeting. Okay, bado niko. So yeah, so that's the graph we're going to implement. Let me do it faster. I copy this. So I come here. This is what I have copy pasted. This is the import that I am doing. I am copying the start. I'm importing the start. I'm importing the end. I'm also importing these other ones. We're going to see how they work when I start writing the code. So we've implemented the LLM, but now we're going to create a function that actually calls this LLM. Instead of calling it directly, we're going to call this function const call model async. So it takes in a state, should take in a state. It takes in a state, and then it does LLM.invoke that we've already been doing here. We've been doing here LLM.invoke. So it does the same thing, but here it doesn't take an input. It takes in state dot the messages. So that this ensures that it has the history of the messages that we've been conversing on, and then it reads this response. So we're going to do message messages response. So once it has run, it has been invoked, we generate the response, and then we send it back as an object with messages. So that's the function that is going to call the LLM model. The next thing we're going to build is called a workflow. A workflow is this that we have already seen here working. Let me show you the code first. So this is a workflow, how we define a workflow in Langchain. You call it workflow, you can call it whatever you want to call it, but it takes in a state graph. And that is this this is just defining this look that we have here. It's just defining this. As you can see hapa kwa code, it is starting with a model, and it's the function to call the model is this one, tumeita call model. It is defining the start. Tuko nayo hapa. This is the start. It is defining that the start is connected to the model, like this here. Start is connected to the model. This is the model or the LLM. Here we can call it whatever we want. If you call it here LLM, you do LLM. And then you say that the LLM is also connected to the end. See here the end, we call it end, but I'm just going to call it model because that's the standard way of using it. So yeah, that's how you define and a workflow is how your application is going to run once it has started being run. So once you start running it, it's going to start at the start node. And then since the start node has been connected to the LLM first, it's going to go directly to the LLM, execute what needs to be executed at the LLM level or the model level. And then if there is a function that needs to be called, remember this image, if there is a function that needs to be called, then it calls that function. If there is none, that's what these arrows mean. So so it does check. If there's a function that needs to be called, if that is true, it calls that function. If there's none, it goes false. So if there's none, it goes to the end. So that we have implemented there. Next, what do we implement? Implement here memory for the application. So this is the memory. So here we define memory, and we define it as memory saver. This is a package. This is a function that we imported here from Langchain LangGraph. It just helps us to create a memory for our AI system. So that's what this does. So we've called it memory. And then we define the application. The application is defined const app, and then you workflow.compile. You pass it to it the memory that we want it to have, so that it remembers what we are, the conversation that we are having. So you've defined, you see this workflow we defined here, workflow, we're telling it that when you compile, you ensure that one of the checkpoints that you have is that you keep memory. Instead of losing memory, you ensure that you have the memory, or the state in which the AI system is in should have memory or conversation history, in short. So yeah, that's it basically. The final thing that we need to do before I finish is this. You remember the ID I told you about, the one that is generated to reference each conversation? We are going to do this. So const config that, and then it generates a UUID that looks like the one we have on ChatGPT. So you're going to see that how it looks. I'm going to show you. It looks like the one on ChatGPT. So we're going to see that working. So finally, what we've remained to do is now to create a loop that loops over and gives us the ability to chat with the application or console. So since we've imported all these, we've defined the function that calls the model, we've defined the workflow, that the workflow is a structure of the graph that we are using. And then we've also set up the memory to store the conversation history. And we've also set up the config. This is just the UUID thread. So I don't know if I've imported that. Let me import it like that. So we come here and import it so that it works. This, I hope that error goes. Yeah, the error goes. So that's correct. Let me finish up. So we're going to start const main async. We're going to, let's remove this. We're going to start by defining something called read line. So for those who are familiar with Node.js, this is how you, in JavaScript in general, this is how you read inputs from the console. So this console will welcome blah blah blah. That's just to welcome the person using the application. But here you define the read line that will be able to take in an input, and then it will also be able to output the response that the AI has generated. So we've just defined this part. We're going to use it to get an input from a user. So we've defined that, and also let's define conversation history. And the conversation history is going to start with this system, this role. So we've seen that we have different roles. So one of the roles that we have is we have the user role. The user role is the one that the person who is using the application is going to be defined as. Then there's the assistant. The assistant is the AI itself. So for example, here we can have the assistant from OpenAI, which is GPT-4o. So that is our assistant. Then the system is how you want the AI system to behave like. That is the system message, the system role. So the system is just you, the developer, defining what you want the AI to do. You can tell it, you can just input it like this, such that it is a starting point for the application, or you can also input it here such that useme respond in French only. This system responds in French only, something like that. So these are the three roles that we have for an AI system: the user, the assistant, and the system. So we've defined the conversation history. And remember, the conversation history is a list of message objects like that. So yeah, so that's the conversation history. Now we need to create a loop function that keeps running so that we can be able to continually get the user's input and continually respond to the user input. So we're going to do async function. We're going to call it loop. So it's going to start this loop. We are going to call it here chat loop. But before we get there, let me not even go ahead of myself. We're going to use the read line that we defined. Remember, we defined the read line here, but you see it's not being used. It is grayed out. You see, unused constant read line. Now we're going to use it to get the user's input. So we're going to do readline.question. And we're just going to tell it to look like this. Let me just Control Z that so that we go step by step. Question, and we're going to tell it. This is just to show the user how we want how it is going to be seen in the console, so that we tell the user that it is your turn to write in the console. So we're going to do that, and then we're going to put in a function here. Async that's going to take in usage. Sorry, is a message. Then it's going to do if the user message is if the user message dot lowercase is equal to it, then we exit the application, readline close, and return. But if it is not, we continue with the application, and we're going to do conversation. So the one that we defined here, conversation history, the one we defined here, we're going to take it and then append to it, push to it the user message. So we're going to take conversation history that we defined, and then we're going to push to it a message object. So user and then the message object, the message text. So first of all, here we are checking to see that the user's message is not exit. If it is exit, it will exit the application. But if it is not, it will append, and it will push this message object to the conversation history, so that the application, when it is being invoked, it has the history of what has been discussed. So we're going to do that, and then we're going to do const AI response. We're going to do AI response, going to be what we did earlier, await LLM. We're not going to do LLM this time around, because remember up here we defined our application, and our application contains the workflow. You see, the application contains the workflow, and the workflow contains the model that we're going to use. So we're going to use the application that we defined. We're going to do app.invoke. It works the same way as LLM.invoke. So it takes in a message, it takes in a list of messages, like we said earlier, conversation history, and then since we've given the conversation history, we also need to pass in the config. This config is the one that we defined as the UUID, that string of numbers that is always unique for a specific conversation. We are going to pass it in here, so that this conversation is always referenced by this config number or string of numbers. Okay, we can also we can do that. Before we go ahead, let's change this to just output, so that we call the AI response to be the output, so that it is more it is the exact content of the messages, the output. So you remember down here, let me show you. Can remember here the AI message, this output, the one we do after LLM.invoke or app.invoke, comes out like this. It has so many unnecessary data that we don't need. We just need the content. So this is the output, is this AI message, but we need output dot. Now for this case, for the case of application.invoke, it has a list of messages. So since it has some history, it has a list of messages from the first message that it got to the last message that has just been output by the AI application. So messages, and then we want the last message, because the last message is the most recent message that the AI has generated. So we're going to do messages dot length. After we're going to do output dot messages dot length minus one. Minus one is the last one. So minus one. If you leave it like so in simple JavaScript, you do messages and then you do zero. Zero is the first one, because JavaScript is zero indexed. JavaScript is zero indexed. Python is also zero indexed. So inside these box brackets, you put in a number, or you can also put in an expression that generates a number, so that you get that. So this is our expression that generates number is just the last one. So for example, if you have 5 messages, it's going to do 5 minus 1 and give you the fourth index, which is the 5th element. I hope that makes sense. The 4th element, the 5th conversation is the 4th index because inaanzia 0. So 0, 1, 2, 3, 4. Hata ukifanya vidole 0, 1, 2, 3, 4. The 5th one is index number 4. So I hope that makes sense. And then we do dot content. You remember our console, tunaona content ni your name is Alvin Kamau. So that's exactly what we want. So content, and then yeah, so finally coming to a close. I hope I haven't disturbed anyone's schedule. So console log, we do AI, and then we do the response. Let's copy this, and then we do. So for those who are not familiar with script, or for those who are familiar with, for example, Python uses F strings, but for JavaScript, this is how we do it. You do backs. I don't know. I call it back. I don't know the name of this character anime. How just now, but you do this one. It's not the single quote. It is this back quote. I don't know what's the name of this one. Let me search. It's called. I hope I don't commit it. Okay. Back there, that's the one. So it uses that backtick. So you put the backtick, and then you do $, curly braces, and then you use that to input any variables you want to input here. Like for example, the AI response that we have. So this AI response, we have inputted here. Let's close that, and then once we have the AI response, we can run it. Let's run it now and see something before we continue. I'll just take 5 more minutes of your time. So we can see here, welcome to the chatbot. Let's say my name is Alvin. Let's see what happens. Notice that the application does nothing. Once it has taken in my input that my name is Alvin, it doesn't do anything because we haven't called this chat loop function. You see, it says unused function, so it is not being used. Define that we want to use the headline, but it is not being called anywhere else. So we need to call the chat loop function. So we come here, and then we call it inside of it. So it's a word that is used to call it. So it keeps running until when the user types in that's exit. Remember what is it that we defined in this function, this if statement. If the user message is it, we close the conversation. So let's try it again and see if this works. I'm just going to call it outside. Let's await it. Okay. It is our term because it is now entering this function, this chat loop function, and then it is defining this read line question and is saying you. So it is taking in a question. Let's say my name is solving. There's an error. Let's see what the error is. Expected key dot to string to return on received type of input. Expected node messages to return object received and okay, here you remember here hapa kwa conversation history we need to define it deeply because we are using app.invoke. It is not necessarily exactly the same as lm.invoke, but here we need to pass in object that is that has a key called messages, and we pass it the list of messages that we called conversation history. Remember the conversation history here is the list of messages. So here we need to pass into it this object, and then the key is messages and the value is a list of messages. So I hope this time it will work. So my name is okay. So now we can see the response. Nice to meet you, Alvin. How can I assist you today? But I want to ask you a question. And my next question will be, what is my name? For those who are able to understand, this will not work. Let me tell you why. It will tell me that it doesn't have oh, it's working, but it shouldn't necessarily work because we haven't pushed the conversation history after we have generated the output. So for example, you see we are generating an output here, and then it is and then we are cleaning up the code, and when we are outputting the content, but this is being saved into our conversation history. So what we need to do is, once we have logged it out, we need to do conversation history dot push. I don't know which is the best example for me to show you that if we don't do this, it will not have the information from assistant. So we can ask it, like for example, let's try. Let's try who succeeded Kibaki. Okay, then let's ask, what was his previous role in government? Let's see if it will have. You see, I don't know if this is working. Before succeeding, I don't know why it has, but I hope you understand that you need to do conversation history dot push so that you push the AI response, so that it has, if there's information that the AI generated that was not in the prompt itself, like this prompt might have some context that the AI is using, but if you do not push the response from the AI into the conversation history, it will not have that context. So that's what I just wanted to show you. I don't have a good example, but this is what you should have. So I hope this helps you understand how to build a chat application. In the consecutives that we're going to have, we're going to build on top of this such that we are going to integrate it with other tools. So we're going to build an agent, and an agent is, in simple terms, an agent is a computer program that can interact with its environment. So the agent we're going to build is going to interact with its environment, meaning that it's going to use tools available to it in its environment. So it's going to use a web search, for example. It's going to do a database search. It's going to do a search over a piece of text you're going to give it. So things like that. So I'm sorry for taking much of your time today. Yeah, that was not my intention, but I hope that every one of you has learned something and that you're excited and interested to learn even more for the next classes. So if you have any question, I am willing to hear them right now so that I help you out. Any questions? Any comments? Things like that. Oh, sorry, Philip. I hadn't seen your question. Can you get us now as we install so we can move on together? I hope that the way I explained on installing the packages, I hope that was clear. I don't know if Philip is still around, aniambie kama niliexplain well enough. I can't see him, but I hope the ones who are still here, I hope I explained enough, well enough, how to to implement to install these packages that you're using. First of all, you need Node version, I think version 18 and above. Personally, I'm using Node version 20. You also need to install then Langchain, the packages. So you just need to go to that link that I shared, and then you follow along, and you'll be able to implement what I just did. Ken is asking, so Langchain supports only the list. Yeah, it only supports those ones, but one of them that they haven't listed is Llama 3, but that is only for local local usage. It's not, you need to implement Llama on a local machine. So whether you're going to do it on Google Colab, so that's for you to decide, or if your machine is able to do so and you're able to implement it on your machine, that's for you to do so. Another thing is Langchain for JavaScript and for Python are being maintained by different sets of people. So the one for JavaScript is slightly behind the one for Python. So if you want to implement using Llama, you'd rather go for Python because it's a bit ahead the in the maintenance. So things like that. Also another challenge, if you're good enough in writing code, you can go to the Langchain GitHub repository and look at the ones who are trying to, and look at the pull request for the ones who are trying to implement the functionality with Llama or any other open source AI, and you can help out there by implementing the requests that that will have been put across. So yeah, I hope I've answered your question, Ken. Any other question before we leave? I do not want to keep you guys any longer. Um, I think that's it. If you have any question, just ask for group. I've been quite busy the past few weeks. Hata last week hatukuweza kuhave a meeting, but as we continue nitakuwa na post news ama just articles and things to do with AI kwa group. So keep a lookout for that. Na pia nyinyi, if you have anything you'd like to share, just post it kwa group and we'll be very grateful for that. Thank you so much for you guys for coming and staying around for that long. I really appreciate it, but I promise that sitakuwa na take too much of you guys' time. Sawa. Have a good night, nyi wote.